Think of machine learning algorithms as an armory packaged with axes, swords, blades, bows, daggers, and many more. So we have various tools, but you ought to learn to use them at the right time. As an analogy, think of regression as a sword capable of slicing and dicing data efficiently, but incapable of dealing with the highly complex data. On the contrary, support vector machines is like a sharp knife. It works on small data sets, but on complex ones. It can be much stronger and powerful in building machine learning models. The diagram you can see right side, right? There is a line here, so a linear line, and there are here right side some dots, and here left side some dots are there. So this line is called hyperplane. So what is this hyperplane? Is n-dimension Euclidean space that distinctly separates the data points. Distinctly separates the data points. So what is this Euclidean space? Euclidean space is a space in any finite number of dimensions in which points are designated by coordinates, and the distance between 2 points is given by a formula, distance formula. So he was an Egyptian mathematician, and based on his name only the Euclidean space came into existence. So whatever you have in the graph designated by the coordinates, so one for each dimension, and the distance between 2 points is given by the, if you want to find the distance between 2 points using a formula, it is possible. For example, x1, x2, y1, y2, 2 points are there, and you want to identify the distance between these two things. There is a formula available which you studied in the school. And both x1 and y1, 2 points are there. You want to find the difference is called simple one, y1 minus x1. So for 2 dimensions, 3 dimensions, how do you find the distance between the points set by the Euclidean? So hyperplane is an n-dimension Euclidean space that distinctly separates the data points. What are the points are there? It separates it. Okay. So data points on either side of hyperplane belong to different classes. So all these things one class, and these are belongs to another class. So the data points on either side of the hyperplane belongs to different classes. Suppose if we have p dimension feature set, the feature set consists of p dimensions 1, and what is the dimension we get for the hyperplane is called p minus 1. P minus 1 will get it. So hyperplane has decision boundaries that help classify the data points. So data points falling on either side of the hyperplane can be attributed to different classes. Also, the dimensions of hyperplane depends upon the number of features. There's a number of features. It is possible for us to identify the dimensions of the hyperplane. For example, the number of input features is 2. Example, number of features of the is called 2. Then hyperplane is just a line. Because of p minus 1 we have now. So what is the feature set consists of? There 2 features are there. The dimension you are going to get is called only 1. So then hyperplane becomes the 2-dimension. Suppose example, the number of input features is 3. Then suppose if number of features are 3, hyperplane becomes the 2-dimensional plane. It becomes difficult to imagine when number of features exceeds 3. Suppose number of the 3, 4, 5 getting that is called. So very difficult to represent also all these things also. There is also one limitation of hyperplane also. Of course, we go up to the 3 levels, 3 dimensions, 4 dimensions, how do you represent, 5 dimensions, how do you represent, but applications also not required that much. Up to 3 dimensions only we go, 2 dimensions, 3 dimensions only we'll use it. Then come to the second point. What is meaning of support vectors is? Just now I said what is meaning of hyperplane. I said this is just one lane which differentiates the 2 classes, as simple as, right? Now what is meaning support vectors? So class is about support vector machine. So what is this support vectors are? You can see right side. So small margin and large margin, these things are there. Okay, small margin, large margins. So all of you hear this particular topic. If you open the book or hear any YouTube video, other videos, you get difficulty to understand all these things. So very simple to understand, not tough task is there. Only thing is called you need to have called attitude to understand this topic is. Your mindset should be there. If your mindset is ready to understand the topic, then you can understand. If your mindset is not ready, I can't help you. Remember that. And data points I said already. There are data points now that allowing you to identify the classes are. The individual data points that close to hyperplane are called support vectors. In this one, these are the data points. You can see green here and you can see blue here, and you can see green and blue also. And here now called, which are here now close to hyperplane. I said now this is the hyperplane. One lane, one plane. So what are the here now called very close to the data point which are close to this hyperplane are nothing they call support vectors. Supporting vectors. This helps you to support, helps you to do that one. We need how called supporting. Suppose now one you said is a statement. Somebody will look for the color. I need support of this one. Okay. And what is called vectors? Okay. So an array, a single dimension array. Because all data points we have. This is it. So support vectors are data points that are close to hyperplane and influence the position and orientation of the hyperplane. So using the support vectors, we maximize the margin of the classifier. So deleting the support vectors will change the position of the hyperplane. So these are the points help us to build our support vector machines. So a very data points are that closer to the hyperplane and influence the position orientation of the hyperplane. Definitely, because the gap between this one is called these are the close. This and this green are very close, and this and these are very close. Okay. So these are close here now. There are two lines have been drawn. Two lines have been drawn. And the distance between the here to here so the distance between this one here now, the left margin and right margin we have, which we'll discuss next slide. And here now called distance between this to here and this to this is same. And also, what are here now called? How do you write here now? From here to here, we'll start calculations. We start calculations. Now, which is this one is here now. We came to this one is okay, very close to here now. So we got two of them, two vectors we got it, and here we got three vectors we got it, right? And here now, suppose if you change these vectors, automatically the margin also changes. That's what he's talking about. Using the support vectors, we maximize the margin of the classifier. Okay. I tell you, explain this point. So deleting the support vectors, if you delete these vectors, suppose example, will change the position of hyperplane. Automatically changes. Hyperplane changes. So these are the points that help us to build the SVMs. How it's possible? I'll explain. And I said just now margin is. I'll back to the previous slide again one more time. Let me explain this point and again I'll come back. And this is the margin we have. Okay. So this is called maximum margin and this is positive hyperplane and this is negative hyperplane. So this is negative side and positive side. And here negative is nothing but a cause. Here don't take it as a minus like this. Here in this consideration is called which are not falling into your data set. Okay, which are not falling according to your condition. There are the classes are there which are not falling into your condition. These are called negative. Which are falling into this one is called positive. Applications point of view you need to understand, then it's possible for you to understand what is negative as well as positive is. So this is maximum margin hyperplane. The width of that boundary could be increased by before hitting a data point. In simple terms, the distance between the hyperplane and support vector is referred as the margin. The distance between this one to this one and this one can be referred as a margin. So large margin intuition. Okay, large margin intuition. What is this one is? In logistic regression, we take the output of the linear function and scratch the value within the range of 0 to 1 using the sigmoid function. As you have seen, that is called. So sigmoid function returns the 0 or 1 and that will be used in the logistic regression. So take the output of the linear function and scratch the value within the range of 0 to 1 using the sigmoid function. If the scratched value is greater than threshold value, we assign it to a label 1. Generally, we have taken a 0.5 as threshold value So we got more than that one, we'll assign to a label 1, otherwise we'll assign to label 0. So in SVM, we take the output of linear function, and if the output is greater than 1, we identify it to one class, and if the output is negative, we take it as another class. So now SVM, also we use some linear functions, and what are the output we got is greater than 1. So we identify it as one class, otherwise we'll take it as a one other classes. Since the threshold values are changed to 1 and -1 SVM, we obtain this reinforcement range of the values called -1 to 1 also. Sometimes we'll get the values also -1 to 1, which acts as a margin. Now it's acting as a margin for us. This is -1 and this is +1. We are showing the image, the largest margin is found in order to avoid overfitting. That is optimal hyperplane at the maximum distance, and the positive negative examples equal distance from boundary lines. And linear problems, linear separability. Yesterday I said about this also. So a data set is linearly separable if there is at least one line that clearly distinguishes the classes. This is called for linear problems. So what you get is like this. There is a line which distinguishes the both classes, that we can say that linear separability is possible. Also it is possible non-linear separability is also possible. So this is non-linear here now. Okay, it's not possible. You cannot try a linear line is not possible here. Also, what you have is called hyperplane is also not possible for linear non-linear problems. Only for linear problems only it is possible for you to do the hyperplanes. And then automatically margins also possible for us. So non-linear separability also comes. A data set is said to be non-linearly separable if there is not a single line that clearly distinguishes the classes. So it's not possible to do that work. So we have the exercises also to how to work with the non-linear problems also. Now, so we'll bring all the terms, terminologies, whatever is there in the support vector machine into here now. So what are the words I said? Let me again say one more time, because these are words comes very frequently for us. I said what is meaning of hyperplane. So hyperplane is a line you're drawing to differentiate the two data sets. Okay. So generally we'll get here now a p-dimension data set feature set we have. The dimensions of hyperplane will be p-1. So suppose for example 2 dimensions hyperplane will be 1, 3 dimensions hyperplane will be 2. So 4 dimensions feature set will get 3 dimensions one also. So support vectors. So that allows us to identify the margins. We need to have margins for this one. A margin will be drawn. Okay, we have some calculations available. Using calculations, it is possible to draw the line and to identify the margins. There are formulas available, functions are available. Using functions, it is possible for us. And there are support vectors are there, which are nearer to the margins, are called support vectors. So we have the margins, and we have called large magnifier, called margin institution, and we have called linear problems and non-linear problems. And what you have is called supporting vectors. So it is supervised machine learning algorithm. So SVM is a supervised machine learning algorithm that can be used for both classification purpose and regression purpose. Both will use it. This one is. So, however, it is mostly used in classification problems. In SVM algorithm, we plot each data item as a point in n-dimensional space, with the value of each feature being the value of a particular coordinate. Then we perform classification by finding the hyperplane that differentiates the two classes very well. These are the support vector machines. So how does this SVM work? You need to understand. To go for this one, how does this work? Let me say some other points are there. What we can know. So why SVMs are used in machine learning is, so drawing a hyperplane, identifying the margins, okay, left side identified. So what are the applications where we are going to use this particular concept is required to be known. Then after that, we'll come to this one is. So why SVMs are used in machine learning? SVMs are used in applications like handwriting recognition, intrusion detection, face detection, email classification, and in web pages. So all these advanced applications, we use this SVM. Example, handwriting recognition. So signature verification. The banks will want to do signature verification on a check. Okay, they can use this particular logic keys. How does it happen is called. Already there is signature already available in the data set and new signature available. So we need to verify that both signatures are correct or not. So in the verification process, we need to perform this SVM. And face detection, one more. So features of a particular person face is similar to other person already taken photograph of the person, both are matching or not. So face detection, we use these SVMs. The classification of emails already have seen, that is called logistic regression. So if we want to identify spam or not, this one can be used. So you can say SVM is a extension of logistic regression also. Extension of logistic regression can be referred as SVM also. That's why email classifications. So I want to keep my mail in a particular folder. As of now, you're keeping your mails in a folder based on the nature you are identifying. Without human intervention, automatically I would like to store my mail in a particular folder. So how do you do that one? That is possible through classifications. So what type of mail we got it, and based on the content of the mail, I would like to store. So content reading of the mail is also required, na? The string processing. As of now, you are doing the string processing, na? Like this. Here also you can read the mail and content, based on the content, it is possible to identify which class it belongs to. In the web pages here now called, I would like to read the entire content. I want to identify which class that belongs to here now, right? That is also possible here now. So I said SVM handles both classifications and regression, and both the data, not only linear data and on non-linear data also it is possible. SVM works. So advanced here we don't have, only basics we have, only 2 topics set in the syllabus. That only we'll see that. Basics I explain you, and later on by using the various sources, it is possible you can expand this particular subject is. Another reason we use SVMs is because they find a complex relationship between the data without you needing to do a lot of transformations on your own. So data processing, if you want to do it, that's possible using these SVMs also. It's a great option when you are working with similar data sets that have tens to thousands of features are there. They typically find more accurate results when compared to other algorithms because of the ability to handle small and complex data sets. It works for both the data sets, simple, so small data sets as well as complex data sets, it works. And what are the here now called? Come to here now, applications point of just now I said. So handwriting recognition, intrusion detection, face detection, email classification, and gene classification also we'll use it. This one is. What are the pros and cons of using SVMs? Pros, what you have is effective on data sets with multiple features like financial as well as medical data. Especially medical data and financial data is very effective one. Effective in cases where number of features is greater than the number of data points. The number of data points are more as compared to number of data points, then is very effective. Uses a subset of training points in decision function called support vectors, which makes it memory efficient one. Different kernel functions are available, which the next topic is about kernel functions only. So various kernel functions can be specified for decision functions. There are some limitations also using these SVMs. Suppose now, so works best on some small sample sets because high training time. So what you have is a small set is there, even though small sample set, so it needs high training. So the training required to be given for small as well as the larger is same. That is one of the limitations here now. For small set, it should be lesser. The number of features is a lot bigger than the number of data points. Avoiding overfitting when choosing kernel functions and regularization term is very crucial. So choosing a particular kernel function is one of the tough tasks for the given data points are. Which function to be used? Various functions are available. Which function to be used when the data is becoming the larger and larger? Then we'll get some difficulty. Otherwise, very useful one. Some very limited limitations, but advantages are enormous advantages of using this particular SVM is. So how does SVM work is a fine. How does it works? So identify the right hyperplane, scenario 1, where you have 3 hyperplanes A, B, and C. Now identify the right hyperplane to classify stars and circles are. So all the data points whatever we have will enter into the graph. Okay, all the data points would be entered into the graph. And once the data points are entered, so which lane should be taken into consideration? Hyperplane A, or B, or C? Which one to be considered? So now, if you have taken A, now this one A is there. Now, once you have taken A, left side of this is all stars getting, but we are getting the red dots also getting. So A is not suitable for us. Now we go with B. When you have taken the B here now, so left side all stars are there, right side all dots are there. So what is suitable one? When you go for C like this, now it has come here now on the C. Okay, so it's taken the C also on the C on the star. The C line has gone, and here also on the red also. So, but we are not getting exactly C. So based on all these things, B is the, you can consider B is the one hyperplane. So left side all star marks there, right side red dots are there. After identification of the hyperplane, we need to identify the margins. We need to identify the margins. So how much distance we go from here to here, how much distance we go from here to here is also required to be known, right? So there are formulas available. So using formulas, it is possible to go. And there are functions available. Using functions also, you have to draw the hyperplane. There are functions available. Using functions, you are doing. So manually you are identifying, but machine how you identifies it is also required to be understand. So identify the right hyperplane, scenario 1. Here we have 3 hyperplanes, A, B, and C. And identify the right hyperplane to classify the stars and circles. We need to remember the thumb rule to identify the right hyperplane. Set the hyperplane which segregates the 2 classes better. In this scenario, hyperplane B excellently performed this job is. So identify the right hyperplane. This one is scenario 2. So all data values are here. Now we need to identify this one is. Shall we go for A, B, or C? Which one to be considered? So here, maximizing the distance between the nearest data point and hyperplane will help us to decide the right hyperplane. This distance is called as margin. Okay, the distance here now, maximum distance between the nearest data point, either class and hyperplane will help us to decide. Suppose I have taken consider B as a hyperplane for me. Now, how much distance is there from here to this is nearest data point, and here to here data point is also required to know. Here in this one is very near and is very far, so B cannot be considered. And so C here now taken here to here and here to here, somewhat average you got. A is very near and is very far, so A cannot be considered. So C can be considered as a hyperplane. That one he talks about. So above you can see that margin for hyperplane C is high as compared to both A and B. Hence we named the right hyperplane as C. Another lightning reason for the selecting the hyperplane with higher margin is robustness. So if you select a hyperplane having a low margin, then there is a high chance of misclassification. So margin should be as much as possible. The distance should be very high. Generally, it is possible you can do the classification very easy. If you are taking the very nearest one, suppose B is taken, very nearest is taken, then classification is not possible to do it. That's why you need to take such a lane where the gap between the nearest data points to the hyperplane should be very higher is.